Hello everyone, welcome to Chirag PostgresQL DBA tutorial. In this video, we are going to learn how to configure PostgreSQL performance tuning and optimize your database just like a pro. So tuning the Postgres database is a journey, not a single step. So day by day, you have to solve your problem. You have to go through the logs. You have to go through the configuration, then go through the entire process on the I'm doing in the Ubuntu 24.04 LTS server, and from the default installation to a 21 and clear example and test the show the differences. Okay. So our training plan is install the PostgreSQL on the fresh Ubuntu server 24.04 LTS, establishing a baseline, create the test database, run the simple workload to the see the before performance, and tune the PostgreSQL to so that is the methodologically adjust the most important configuration parameter in postgresql.conf file. This is a configuration file from the PostgreSQL database, and test again, run the same workload to see the after the performance and qualify the improvement, review key OS level optimization. So prerequisites are there: a machine or VM with the Ubuntu 24.04 LTS, and I am using the IP address 192.168.126.128, and I am using the 8 GB of RAM. Here we are using the 2 to 4 GB. So RAM, and I'll check adjust through that. I'm using 8 GB. So okay, no need to write. So in step one, installation and setup. So installation, for that we need to the our server. So server is ready. Server is running with the VMware workstation. That is the Ubuntu 24.04 LTS version is there. I'm going to access this one. IP address is this for now. CMD. So SSH DPT is the user. While installing, I have given the user. So password admin at the rate 123 sudo su. So, clear. So side by side, I'm gonna do this. So this is done. I'm going for the update the system, whatever system packages, and upgrade that and installing the PostgreSQL and contribution libraries. So run at once. So let it complete. We'll go through the next. So next we'll just verify the installation. For that you can check with the status of the Postgres service, and there is a PSQL or the version. So PostgreSQL version you can check. There is 16.x will be installed there because Ubuntu 24.04 automatically just keep the repository for the PostgreSQL 16. So it will give you the 16. And next we'll just set the password the Postgres user. By default, Postgres user the peer authentication for the local user. Let set the password the Postgres admin user so that we can connect remotely and locally with the password. So copy this. So you can see that is active and running. Now check the version. So we are using PostgreSQL 16.9. Okay. So set the password with the Postgres user. So previously this was in the root user. Now this is changed to the Postgres user. Uh, Postgres prompt, SQL prompt. So we are using the Postgres user. User is Postgres, and this one PSQL. So now inside the PSQL prompt, set the password. Set the password. This is the command. So admin at the rate 123. I'm putting the simple password. Admin at the rate 123. Password is set. Okay, so move to the next. So next is the allow remote connection optional. So if you are using from the another machine, then you need to set the configuration. Give me a second. Okay. So now go to the configuration. So we are opening the configuration file /q, exit from the console, open the configuration file, go to the local address. So it will be there, listening address, and here in localhost, and you can add the IP 192.168.136.128. You can connect with the IP also. Okay, or you are allowing to the all the IPs, then you can put the extract. So that's why you now go to the HBA configuration file. So PGHBA, this is the host-based authentication file. There we are giving the IP address of the remote connection for the remote connection. So let me open this, go to the end and add this one. So host, database all, user all, and this is the IP address with all the IP addresses on the this network with the X network to connect if they provide the MD hash password. So copy this and add this one home. So this one the IP address, control X Y. So save this. Now whatever the changes we have done for the configuration, for the apply those changes, you have to restart the PostgreSQL database. So restart that. So restart successfully. Now move to the step 2. In step 2, establishing a performance baseline. So we need to consistent way to measure performance before the and after tuning. We'll create the test database and simple table with the lots of data. So create the test database. So let me log in with the Postgres database form and create a database. Create a user with the password admin@123. Grant all the privileges to this user and come out from there. Exit. Now we are created a simple table and insert data. So let's connect the test user and create the table. We'll use the PG bench tool on which they include all the PostgreSQL to create a simple benchmark schema. So let me try to connect with this. Directly I'm connecting with the test database. Here we are providing the -d database name is test database. So next create a okay password we have given. Now following commands to insert we have to grant for the user. Okay. So done schema public grant all the sequences. Okay, all sequences and all in all table are done. So completed. So now we are going to use the PG bench. PG bench is PostgreSQL built-in benchmarking tool. It is used to test and measure the PostgreSQL database performance by the simulating multiple concurrent client session and running the simple transaction. So initialize the PG bench. So we are using -s means the create 50x scale factor and this will be 750 MB of data approx. So let me run this in bigger size. I'm going to run this one. This is a command. Okay. So enter. There is it will ask to the password. So it will take some time. So let it insert. So completed. Okay. PG bench account. Okay. So now we are running the baseline benchmark. We are running the simple read and write benchmark. We will just run the for the 60 second. For the 60 second, we'll run this. So here I have defined all the parameters minus C10, 10 concurrent database session, and minus J2, two threads we are using, good for the modern multi-core CPUs, and minus T we are running for the 60 second, minus P2 shows the progress every 2 seconds. So whatever the result we'll get, we'll just copy this result to here and we'll just compare later. So remove this result. Okay, completed. Now let me copy this and keep it there. Okay. Now move to the step 3. There is the training of the PostgreSQL database. Okay. So here we are going to the PostgreSQL main folder, and we're keeping the PostgreSQL configuration file as a copy. So here you can able to see this is the main file, and we have kept a backup. Okay. On that file, I'll open this and I'll adjust the this one. So assuming our VM has a 4 GB of RAM, so I'm just changing this one with the 8 GB. Let me check with my RAM. So go to the setting. So we are using the 8 GB of RAM. Okay. So now set buffered. Control W and search. Give this one 1 GB. I'm changing request to that 1 GB. 1 GB. And workman, I'm giving the 10 MB. Just increase for the workman process, work memory process, 10 MB. Next, maintenance work memory. So it will use for the workman maintenance work memory used for the vacuum, create index, and etc. Control W. So this one, okay. So 64 MB. Now effective cache size, I'll give 1 GB or 2 GB. I'm changing the same for the my testing. Okay, done. Now checkpoint related, we'll do that. For the checkpoint, there's a max wall size, 1 GB. Meanwhile, wall size, so 256 MB. Checkpoint completion target will be 0.9 is the default. I'm leaving this one. So spread out the checkpoint IO over 90% of the time between the checkpoints. Next, move to the parallel processing setting. So here the modern servers have the multi-cores. Let them the Postgres to use them. So parallel execution. So I am using the 4 worker to run parallelly. So here 8 worker are there. I'm using the 4. Then max parallel worker per gather. In a in the single query, how many worker will do? So I'm allowing 2. If, and max parallel worker. So system wise, it, it will I'm going to for the 4. Now miscellaneous setting, MISC setting. So random page cost 1.1 lower if you are using SSD. 4.0 is the initial, so 1.1 I am giving. 4.0 for the HDD and 1.1 for the good for the SSD. So I'm using the SSD. Effective IO concurrency higher for the SSD. So I'm giving 200. Okay. So save this file. Then we have changed the configuration. So now I'm going to restart the service. So now same, I'll just run once again for the PG bunch and I'll just take the output. And we'll compare both the output. So remove this one. So it will run for the 60 second, means 1 minute. 1 minute we have to wait. Okay, done. Let me copy this, paste. I'll just compare with the previous one. So this one. So remaining all the things are same. So number of threads is 2, same. Tries 1, 60 second. So number of actually process. Previously it was process 33,000 approx. Now it process 35,000 approx. And the latency average one 60 second now, and previously it was 70 millisecond. Okay, latency is standard dev is 7, this one 9. Okay, so initial connection time, so previously 76, now this one 158. And main thing is TPS, so TPS 598, and this is taking 555. So let me write this one there bottom. So this one is the old result. So previous baseline wise, this one. TPS 555. Now new TPS is 598. 598. So this is an increase. Average latency is 16,267 ms, and now new latency is 5. The previous one latency was 17. New one is 16,267. 267. So here on the output, you can go through that. Transaction per second TPS is previously before tuning this one 555, and now this is approximately 600. If you go to the real and production environment, this will be much difference. So I'm just doing the test environment, and VM is also running in the local system. So this is also a simple reason. So if you do with the production, it will always increase and it will be more after tuning. And average latency was 17 previously, and this one decrease reduction with the some millisecond. So this will help you a lot. So this is done. So there is a some why did this happen? You can go through the this one. So shared buffer, we have work memory and SSD setting. So this thing more important, OS and hardware consideration. So where you are running, this is the most important, and how the modern file system we are using, just XFS and ext4. So the better performance, so that the database workload and IO scheduler for the SSD deadline, or the noob scheduler with the better with the default configuration. You can see, you can check all the scheduler and this thing. So you can check with the VM's configuration also. So everything is good. So final advice for the newcomers: never tune on a live production server without testing. Use the staging environment that mirror production, and change one setting at the time if you are trying to diagnose a specific problem. This way you can know the cause of the change, and use the pg underscore state underscore statement for the PostgreSQL extension. I'll just create a video regarding the statements, so I can go through that also. For the find the slowest query and open the tuning of the single bed query of the more impactful than the general configuration tuning. So query is the most important whenever you are working with the database. You have to look at the statement also for the query, uh, changes and query whatever the this is taking the bad query to good query. And monitoring is the key. Use the tool PG Burger. So already video regarding PG Burger, you can go through that. And there is a Prometheus and Grafana is also there. I've created video for that. You can go through that, and the Postgres exporter to the track your database health over time. So now we have successfully gone through a full basic performance tuning basic. Great job, we have completed this. For any doubts and query, please write on the YouTube video comment section. Follow the process shown in the video. Please subscribe for the more videos. Don't forget to follow, like, share and comments. Hope this will help. Thank you for watching.